Hi, this is Karen Pelletreau from the University of Connecticut.
Brittany Gasper from Florida Southern College.
Eric Warwick from State College of Florida.
And we're here to provide some Small World Initiative instructor guidance videos to help with results and interpretation. The first that we're going to show you are some serial dilution results.
All right. So what we have here are 4 plates. Can we see that?
Mm-hmm.
So we have plates that have gone through a serial dilution series. So we have here, this is a dilution. It was actually a soil sample taken from a water sample, so actually it's from a pond. But the same thing would work if you had a soil sample where you had 1 gram of soil suspended into water. And so what we've done with this plate, this is a 10 to the negative 1 dilution. And so you can see that we have quite a few colonies growing on this plate. So way too many to count at this point for this particular plate. This is after 1 day of growth. And you can see 10 to the negative 2, if we compare the two, we can see we're definitely seeing less colonies on this plate. So this is a sign of a good dilution series. We should see, as we get more diluted, fewer colonies on the plate. 10 to the negative 3, also fewer colonies. And our 10 to the negative 4, we actually don't have very many colonies at this point. Now a couple things to comment on with these plates. One thing is, you'll notice that you don't see a ton of diversity in terms of colony type at this point, and that's nothing to be concerned about. At this point, after 1 day of growth, a lot of the colonies aren't producing any pigments or special textures that they will eventually produce. In a couple days, we would expect to see a little more diversity with this. I also want to point out a couple interesting colonies. So we have here this kind of galaxy-shaped colony right here. Can we see it in there? Mm-hmm. That is Bacillus mycoides, a very characteristic of Bacillus mycoides. This organism is both a blessing and a curse. Oftentimes this organism is known to produce antibiotics, so you will commonly see a zone of inhibition around there. I don't have one here because there's not anything close enough to it to show that. But you'll commonly see a zone of inhibition. Over time, if you let this grow for many days, you will see this organism will clearly and quickly take over the entire plate. So while it is an antibiotic producer and it's very interesting, it is strongly suggested that you not pick it because it's very difficult to get away from it, and it will take over and swarm over your other colonies that might be more unknown and interesting.
It looks like you have some on this plate too.
We do, yes. So we have some on the 10 to the negative 2 plate as well. I don't see any obvious zones of inhibition with the Bacillus mycoides on this particular plate. That doesn't mean it doesn't produce, it just means it may not be inhibiting anything that's growing around it on this particular plate.
So that is one selective advantage of using the PDA plates, is that the Bacillus mycoides is inhibited for unknown reasons.
Correct. And we actually have PDA plates over here. And I should mention that these are TSA plates. And so we have some PDA plates here, and you'll see we don't see any Bacillus mycoides on these. And these also are examples of a nice dilution scheme. We have 10 to the negative 1, 10 to the negative 2, and then a more diluted 10 to the negative 3. Now this 10 to the negative 3 also has something that might show up, and that's going to be mold contamination. So you can detect mold from the other bacteria on the plate by the fact that usually it's going to have a fuzzier texture and oftentimes multicolored. A lot of times it's dark like this is. Sometimes it can be green. Sometimes it can be yellow. You can get all kinds of varieties of color with mold. Blue. Mold, while interesting, is not what we're looking for in this particular course. This is a sign that this plate has grown long enough that the cyclohexamide might now be breaking down. It might not be as functional as it was previously. Or it could be a sign that you need to add more cyclohexamide to the plates. So.
One of the things that was interesting today is the fact that that can be different depending upon what semester you teach the course as well, because your fungal load in the environment can vary, right?
Yes.
Absolutely.
So,
and geographic location.
Geographic location. Up here in Connecticut, where it's not as tropical, they get away with using 25 micrograms per mil cyclohexamide. Down in Florida, where we have a lot of humidity, we have to use 100 micrograms per mil.
And it also depends on your environmental samples.
Correct.
Because some of the people from the northern environments did see some signs of mold contamination. They did have to increase their cyclohexamide concentration to about 50 to 75, even though they were still in a cold climate. So just as a general reminder, when you are doing your titer calculations, you do want to enumerate, get an approximate estimation of how many colonies you're seeing on the petri dish, and that range should be between 30 and 300 colonies when you're going to be doing the CFU calculations.
Right. So for example, if we look at our dilution series here, this plate likely has fewer than 30 colonies. I'm just eyeballing it. So this would actually be not the appropriate plate to do a calculation for a seal dilution. So instead we would go to the more dense plate, so less diluted, and this likely will have between 30 and 300 colonies.
And would you even bother with these more dense plates?
I would not, because at this point you can see how a lot of the colonies are overlapping with each other. We're not going to be able to distinguish what's one colony from two colonies, and therefore your counts won't be accurate.
Well, thanks, guys. I think we'll return with some troubleshooting and interesting encounters we might see on cereal dilutions.